This video will go over lesson 2.1 in your packet. The lesson title is Solve Two-Step and Multi-Step Linear Equations. This is from Objective 2.1 in Unit 2. Notice that during this lesson we are going to be solving two-step equations using inverse operations. Now, inverse operations is one of your vocab words, and it just means opposite operations that undo each other. For example, addition undoes subtraction and multiplication undoes division. So let's go ahead and start with example 1a and see what we're talking about here. The first thing you always want to do when you're solving an equation is make sure that both sides of the equation are simplified. That means, if you remember from Unit 1, that you have to distribute all parentheses and add all like terms. So 7x and negative 4x are like terms, so we're going to go ahead and combine those. 7 minus 4 gives us 3x. That right side doesn't have anything to simplify, so it stays as 21. 3x equals 21 means 3 times x. So how do we undo that 3 to get x by itself? Well, if x is being multiplied by 3, then to undo it, we would need to divide by 3. What you do to one side, you have to do to the other, which is a property of equality also found in your vocabulary. So we divide both sides by 3. Now once you show that, and we want you to show what happens after you do that. So 3 divided by 3 is 1, or 1x. We don't put the 1 as a coefficient, so we're just going to write x equals 21 divided by 3 is 7. Now x is by itself, so we think that's our equation. Get in the habit of checking your equations. Anytime you solve and you think you know what x is, go ahead and plug it into your original and see if it works. So in our original we have 7 times 7 minus 4 times 7. We don't know for sure that it equals that because we're checking it, so I'm going to put a question mark. Equals 21. 7 times 7 is 49. 4 times 7 is 28. Does that equal 21? And yes, it does. So this is our solution. Let's check out example 1b. So here there's a little bit more going on. There's nothing to simplify because there's no parentheses or like terms that need to be combined on either side. So let's go ahead and read our equation and see what we need to do. We have x divided by 2 minus 9 equals 11. How do I know where to start? What do I undo first? I'm going to give you a couple of tricks that may help you. First of all, it's helped a lot of previous students to draw in a line through that equal sign. What you do on one side of that line, you must do on the other. Now, how do I know what to do first? I'm going to give you 3 ways to look at it. First, look at the physical equation. What appears to be farthest away from the x on the same side of the equal sign? The 9 looks like it's farthest away. That's a good hint as to what you're going to undo first. Another way you can look at it is when you read the statement, what do you say last? X divided by 2 minus 9. Well, I said minus 9 last, so that's probably going to be the first thing that I undo. Another thing that you can always do to try to determine what you should undo first is think about PEMDAS, DAS. Sorry, my handwriting's so terrible. Okay, so when we're solving equations, we're actually going to undo PEMDAS backward. So just remember that. If we have addition and subtraction, since it's the last thing on PEMDAS, it's going to be the first thing that we undo. So anyways, we have minus 9, and to undo subtraction, we add. So we're going to add 9 to both sides. That's going to cancel out, and we're left with x over 2 equals 20. And then we just have x divided by 2, so we just have to undo that divided by 2. To undo division, we multiply by 2, and that cancels out. We have 2 times 1/2, which is 1, so 1x, or just x, remains, and 20 times 2 is 40. So 40 we think is our answer. Let's go ahead and check it, just make sure. Just remember, we're going to plug that into the original equation. And instead of just putting equals, we're going to put a little question mark over that equal sign, because we don't know for sure yet. 40 divided by 2 is 20. Minus 9, does that equal 11? Yes, it does. So that means that we solved it correctly. All right, let's go ahead and take a look at these bullet points in the middle of your page. We've already talked about this, but to solve multi-step equations, you're going to simplify one or both sides of the equation if possible. Then you're going to use inverse operations. Apologize about that atrocious handwriting. That's operations to isolate the variable. Okay, so let's take a look at solving example 2a. So when we are simplifying both sides of the equation, the first thing we have to do is take a look at like terms. So we're going to look at these guys right here. They both have an x, which means that they're like terms. So we have 8x minus 3x, or 8x plus negative 3x is 5x. So we can go ahead and simplify those. And then we're going to attempt to get x by itself. So we have 5 times x minus 10 equals 20. Remember those tips I gave you for identifying what you're going to undo first. So any three of those tips would tell you to undo the minus 10 first. So we're going to add 10 to both sides. And that cancels out. We're left with 5x equals 30. I really encourage you to show all of your work on these. Good practice. We have 5 times x. We're going to undo that 5. Since it's being multiplied, we're going to divide both sides by 5. It's going to cancel out, and so we'd have x equals 6. Okay, so we think that's our answer. Let's go ahead and check that out. So we have 8 times 6 minus 3 times 6 minus 10. Does that equal 20? So 8 times 6 is 48. Minus 3 times 6 is 18. Minus 10. What does that equal? So 48 minus 18 is 30. Minus 10. Which does equal 20, so we are good to go. That is our answer. Alright, let's check out 2b. So once again, we have to check out whether or not there's any like terms or parentheses. Here there's parentheses, so remember we do those parentheses first. So we have to distribute, and this negative is part of that number. So negative 2 is going to be distributed. This 6x just hanging out here. Negative 2 times x is negative 2x. Negative 2 times negative 5 is positive 10. So we've distributed our parentheses. Now we're going to add our like terms. 6x and negative 2x are 4x. So we have 4x plus 10 equals 46. Now that everything is simplified, we are ready to isolate x. So what do we need to start with? This plus 10. How do we undo plus 10? We subtract 10. What we do to one side, we have to do to the other. Subtract 10 from both sides. That cancels on that left side, leaving us with just 4x. 46 minus 10 is 36. 4 times x. So to undo that 4, we have to divide both sides by 4. Which cancels on the left, leaving us with just x, or 1x, equals 9. Okay, so then when we plug that into the original to check it, everywhere we see an x gets that 9. So I'm just going to rewrite this exactly like I see it, but in place of the x, I'm going to put a 9. Little question mark here. Okay, so 6 times 9 is 54. Remember, we do parentheses first, so minus 2 times 4. So we have subtraction and multiplication. We're going to do the multiplication first. So 54 minus 8. Does that equal 46? Yes, it does. So 9 is going to be our answer. Alright, so let's finish this video out. We'll go to our last example. So we have two special cases. Special cases are when an equation that is true for all values, that means no matter what you plug it in, it's called an identity. The solution of an identity is all real numbers. Some equations have no solution. Alright, so it's example 3. We're looking at these special types. So remember, first thing we have to do is simplify, so we're going to distribute that 2 to both things in parentheses on this right side. 2 times x is 2x, and 2 times 5 is 10. That left side doesn't have anything to simplify. Now, we haven't talked about this yet, but you've probably seen it. After you simplify, if you have x's on both sides, you have to move them all to one side. I like to move everything to the left, but some students like to look for what side is going to make a positive number. In this case, it doesn't matter. In both cases, you're going to undo positive 2x by subtracting 2x. So no matter which way you move it, you're going to end up with the same result, and that it cancels out. So both of those 2x's cancel out, and we're left with 10 equals 10. When all of your variables cancel and you're left with a true statement, that's when you have all real numbers. And you may want to write that down on your paper. When all variables cancel and you're left with a true statement, your solution is all real numbers. So let's look at B. So we have to simplify first. To add our like terms, negative 15x plus 7x is negative 8x. And on the right, we don't have anything to simplify. So notice again, we have negative 8x on both sides, so it doesn't matter which way we move it. To undo negative 8x, we're going to add 8x, and that cancels on both sides, and we're left with 1 equals 3. When all variables cancel, and you're left with a false statement, 1 does not equal 3, your answer is no solution. You may want to write that down as well. All right, hope everything makes sense. Let us know if you have any questions.